To prove that the square root of 2 is irrational, we can use a proof by contradiction. This means that we will assume the opposite of what we want to prove, and then show that this assumption leads to a contradiction. Let us assume, on the contrary, that the square root of 2 is a rational number. Then, there exist positive integers a and b, such that the square root of 2 is equal to a divided by b, where a and b are co-prime, meaning their highest common factor is 1. Now, let's square both sides of the equation sqrt 2 equals sign ab to get rid of the square root. This gives us 2 equals sign a2 b squared. If we multiply both sides of the equation by b squared, we get 2b circumflex 2 equals sign a squared. Since a squared is divisible by 2, it means that a must also be divisible by 2. Let's say a equals sign 2k, where k is an integer. Substituting this into the equation, we get 2b circumflex 2 equals sign 2k squared equals sign 4k circumflex 2. Dividing both sides of the equation by 2, we get b squared equals sign 2k circumflex 2. Now, we have shown that both a and b are divisible by 2. This means that they have a common factor of 2, contradicting our initial assumption that a and b are co-prime. Therefore, our assumption that the square root of 2 is a rational number must be false. Hence, the square root of 2 is irrational. B-roll change. Transition to a shot of a mathematician writing equations on a whiteboard. If we square both sides of this equation, we get 2 equals a squared divided by b squared. Simplifying further, we get 2 times b squared equals a squared. From this equation, we can see that 2 is a factor of a squared, therefore 2 must also be a factor of a. We can express it as 2 times some integer c. Substituting this value of a into the equation, we get 2 times b squared equals 4 times c squared. Simplifying, we get b squared equals 2 times c squared. From this equation, we can see that 2 is also a factor of b squared. Therefore, 2 must also be a factor of b. However, this contradicts the fact that a and b have no common factor other than 1. Therefore, our assumption that the square root of 2 is a rational number is incorrect. Hence, we can conclude that the square root of 2 is an irrational number. This proof is a classic example of the proof by contradiction method, which is a powerful tool in mathematics for proving the existence or non-existence of certain mathematical objects.